Hey guys, today I'm going to be showing you how to prove that a function is even, odd, or neither algebraically. So we've seen how to do this when we have a graph of a function. Usually if the function looks something like this, then we know that it's even because it's symmetrical across the y. But how do we prove that when we don't have a graph? So when we have a function and we want to prove that it is even, odd, or neither algebraically, all we're going to be doing is taking the variable and making it negative. So as an example, we have here f of x equals x squared. So we're going to replace the variable x with a negative x and see what happens. So we'll write it out this way: f of negative x equals, and now we'll have a negative x squared. So when we go ahead and expand this further, we see that we have a negative x and we're squaring it, which means that we're just saying negative x times negative x. We're just going to get a positive x squared. We can say that for these two, f of negative x equals f of x. In other words, when we change the x to negative, we still got the same result of x squared. So that would make this function even, and x squared looks like that graph where it's just like that. And if you want to try it out with numbers, then you can try f of 2, and that's 2 squared, which is 4, and f of negative 2 will give you negative 2 squared, which is also 4. So if the function is even, then when we take the f of negative x, we'll just get the original function. So let's try another one here. If we do f of x equals x squared plus 5. If we do this algebraically, again we're replacing the x with a negative x, and so this will give us a negative x squared plus 5. And simplified, this will again give us x squared plus 5. So you see that f of negative x equals f of x. Now try to remember this portion here. This gives you an even function. F of negative x equals f of x. So let's try an odd function. Okay, so to prove an odd function, we're doing the same thing. We're going to be replacing the variable with a negative x, but this time, instead of getting the original function, we're going to get the negative of that original function. So what does this look like? So let's say we had the function f of x equals x cubed. So what happens when we replace the x with the negative x? We'll have f of negative x equals a negative x cubed. And what is that saying? Well, we're going to have a negative x times a negative x times a negative x, and that's going to give us a negative x cubed. So in this case, we see that replacing the x with a negative x, we're getting a negative x cubed, which is the original function, except it is now negative. Let's say our f of x was x cubed plus x. So what happens when we take f of negative x? Well, we'll have a negative x cubed plus a negative x, which simplified would be a negative x cubed minus x. And if we factored out a negative 1, then we see that we have a negative 1 times the original function here. Okay, so that means that this f of negative x just gives us a negative f of x. And we can try it out with some numbers as well. Let's try this with an easy number. We'll do f of 1, and then we'll do f of negative 1. So this will give us 1 cubed plus 1, which equals 2. And for the negative 1 function, this will give us a negative 1 cubed plus a negative 1. and this will equal negative 1 minus 1, which is now negative 2. So you can see once we plug in a number into this function, we get a certain answer, and when we plug in the negative of that variable, we get the same answer, but it's now negative. And that proves that it is odd. What's going to happen with the neither function is when you replace the variable with a negative, you're not going to get the original function back or the negative of the original function. So what does that look like? We'll go ahead and do f of x equals x cubed plus 2. So if we plug in a negative x into this function, we'll get negative x cubed plus 2, and this will give us negative x cubed plus 2. And so you can see that this portion does not equal this portion here. And if we plug in some numbers, if we plug in f of 1 and then f of negative 1, we'll have 1 cubed plus 2, which is going to be 3. And if we do the negative 1, then we'll have the negative 1 cubed plus 2, and that's going to give us negative 1 plus 2, and that's going to give us just 1. So as you can see, 3 does not equal 1, so we would say that f of negative x does not equal a negative f of x or f of x. So here I'm going to do one that's a little tougher. We have f of x equals negative 5 x squared plus 4. So first let's replace the variable with a negative and see what we get. So we have f of negative x equals a negative 5 times a negative x squared plus 4. And so this will give us a negative 5 x squared plus 4. So we see that an f of negative x equals f of x, and so that means that this is an even function. Okay, so we'll try one with more terms. We have f of x equals x to the 4th minus 2x plus 9, and we're seeing what happens when we replace the x's with a negative x. So we'll get a negative x to the 4th minus a 2 times a negative x and a plus 9. So if we simplify this negative x to the 4th just means that we're multiplying negative x times itself 4 times. So that means we're going to get a positive x to the 4th. And then the second term will flip to positive since we'll be subtracting a negative. So this will now be a plus 2x, and we'll drop down the 9. And as you can see, this x squared, this x to the 4th plus 2x plus 9 does not equal the original function, and it is also not the negative version of the original function. The negative version of this would be negative x to the 4th plus 2x minus 9. So since f of negative x does not equal the original function or the negative of the original function, then this function is neither. Now let's try 2x cubed minus 3x squared minus 4x plus 4, and we'll replace all the x's with the negative x. So we have 2 times negative x to the cubed minus 3 times negative x squared minus 4 times negative x plus 4. So we're going to get a negative 2x cubed minus 3x squared and a positive 4x and plus 4. So as you can see, this is not the same function, not the original function, and it's also not the negative version of the original function. So this is again another neither function. Okay, and we'll do one more here. F of x equals 2x to the third minus 4x. So replace the x's with a negative x, and we'll get 2 times negative x cubed minus 4 times negative x. And simplified, this would give us a negative 2x cubed and a positive 4x. Now as you can see, the signs on both of these terms have now changed, which means if we factor out a negative 1, then now we have 2x cubed minus 4x. So we have the negative version of the original function. So this function is going to be odd.